Hello boys and girls, this is Mr. Kizik, and in this video we're going to be looking about systems of inequalities word problems. Now, like I said, these are like problems that would be on the keystones where you would have to graph the inequality, and then with it, you would have to write down some possible solutions within your shaded region. So you're still going to do the same thing we've been doing here, basically. Just you're going to identify what your inequality is, you're going to graph it, and then you're just going to pick two possible solutions within your shaded region. So if I look at number one, suppose you buy flour and cornmeal to make tortillas. So let X represent flour and Y represent cornmeal. It says flour costs $1.50 per pound and cornmeal costs $2.50 per pound. We know, remember the word per means multiply, so we know it's going to be 1.5x and 2.5y. He wants to spend less than $25, so we're going to add that together. Now, less than $25. Does that include 25? The answer is no, because he says he wants to spend less than that. 25 would be too much, so less than 25. And then you need at least 6 pounds. So at least means I can have 6, but I can also have more. So x plus y greater than or equal to 6. And now you go about graphing your inequality. So here you subtract 1.5x. So I would have 2.5y less than negative 1.5x plus 25. And then divide everything by 2.5. So when I do that, I have y is less than. So now put in your calculator, negative 1.5 divided by 2.5, and you would get negative 0.6, which is going to be negative 3/5 x. And then when I divide this, I get plus 10. And then if I do the other one here, I subtract x, I get y is greater than or equal to negative x plus 6. So now I graph these. I do have enough room to utilize my graph here. So I can, let's label the axes too. X we saw is flour. Cornmeal was y. Cornmeal. So I can go up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And go down 3 and right 5. 1, 2, 3, 4, 5. And down 3 over 5. 1, 2, 3, 4, 5. And now we would have a dotted line because there's no bar underneath there. And we would shade below. So I'm going to lightly shade below here. Now I do the same thing for the other graph here. I have start 6. 1, 2, 3, 4, 5, 6. Down 1, right 1. Here I would have a solid line. And the shading would be above. So the shading above, that means then my solution is everywhere between the lines. And then remember, I don't need to go below the x-axis because I'm not buying negative cornmeal, and I don't go to the right, the left of the y-axis because I'm not buying negative flour. So what are two possible solutions? Well, the possible solutions are anything in the shaded region here. And like I said, try to pick points that are clearly away from the line because that gives you a good indication that you're right. So if I do like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I do 10 flour and 0 cornmeal, that's clearly away from either line. 10 flour, 0 cornmeal. I'm clearly there. Or how about if I have, don't make it complicated. 10 flour, 1 cornmeal. Clearly away from the lines and clearly in the shaded region. But you can always check too by plugging in these numbers in for x and y of your inequalities to see if you are correct. All right, let's look at number 2. You got a seafood restaurant owner orders perch and salmon. So x is perch, y is salmon. Let's label that here. And sorry, I had markings from before, which I'll explain in a minute. Perch and salmon. Purchase $4 per pound and salmon's $3 per pound. Wants to buy at least 50 pounds of fish. So at least means he can have 50 or more, but cannot spend more than 240. So I'm going to have 4x plus 3y. Now, he cannot spend more than 240, but can he spend 240? The answer is yes. Just can't spend more than that. So less than or equal to 240. So going with both of these here, I have y is greater than or equal to negative x plus 50. And for the other equation, I would have, or solve for, I get 3y less than or equal to negative 4x plus 240. And then divide by 3, and I get y is less than or equal to negative 4/3 x plus 80. Now, hopefully you realize here that clearly I don't have 50 spaces or I actually need at least 80 spaces on the y-axis here. What you could do, let's see, does it work? 10, 20, 30, 40, 50. I'm just saying here 10, 20, 30, 40, 50, 60, 70. Now, so I cannot go up by tens here. So what I can do is I could go up, I can try it again. I cannot go up by fives here, but I could have each space go up by tens. Now, if you remember back when you first started graphing, whether it was this year or last year, you always want to kind of do the same intervals on both axes here. You don't want to go like tens on salmon and then go ones on perch. That just doesn't make sense. So we can go up by tens here. So it'd be 10, 20, 30, 40, 60, 80. Remember, I can skip that, but we're going by 10. We're going up by tens, and the same thing here. We go 10, 20, 30, 40, 50, 60, 70, 80. Just all that. And the reason what makes this great then is because if I have both axes with the same intervals, I can still do the slope without having to worry about really how much I need to go up and down. Because if I look here, if I do the first one, the 50, so 20, 40, 50 right here, if the perch was a different interval, I wouldn't be able to do what it says here, go down one, right one. I'd actually have to go between the blocks here. So by having the same intervals, I can go down one, right one, put a dot. Down one, right one, put a dot. It's a solid line here, and the shading would be above. The next one here, same concept. I would, okay, no. Actual size. There you go. I have to go start at 80, so 20, 40, 50, 80 right here. And I go down 4, 1, 2, 3, 4, and over 3. 1, 2, 3. Down 4, 1, 2, 3, 4, over 3. 1, 2, 3. And then my line will be a solid line. And my shading would actually be between the two lines, right? Because of less than. So my shading is right here. Now, what can make this a little bit difficult is because, again, we have such a narrow space here because of the intervals. If we were able to make smaller intervals going by fives instead, we can probably see a better picture, but we have to go by tens. So here, looking at intervals, again, pick ones that are clearly away from the line. This point right there is clearly away from the lines. So if I have, looks like 60, if I have 0 perch, 60 salmon, that works. Now, I always have a lot of students giving me like the points, the corners here. But remember, everything between is still a number, right? I mean, even though we're going by tens, I can pick, 25, which would be like right here. Say I did 25 perch, that would be right here. And if I went up, I could pick something in the middle right here. Doesn't have to be exact, but I could say, 35. So what if I pick 25 perch and 35 salmon? again, the best way to check just to make sure is to plug it in for x and y of your problem here. Let's look at, let me just see what I got here. Okay, let's look at another one. One more together here. So I look at number 3. We sell CDs, plans, blah, blah, blah. Okay. Their operator will spend no more on this advertising adventure. So, and then it costs $30 to appear in a weekday paper and $50 to appear in a weekend. They plan to run at least 20 ads. So, we want to write a linear inequality to basically see what kind of ads we can have here. Now, in this case, the X and Y are your weekday paper and your weekend edition paper. So, weekday, weekend. Again, the whole thing is ads, but it's a weekday and weekend. So, looking at the budget here, to spend at most $3,000. So, do that. Let's see, weekday was 30, so 30x plus 50. Whoa, what happened there? 50y is less than or equal to 3,000 because it said again at most, so I can spend at most that. And then he wants to run at least 20 ads, so 20 or more. Solving for each one here, I would have 50y less than or equal to negative 30x plus 3,000. And then divided by 50, I would have y is less than or equal to, looks like negative 3/5 x. And then 3,000 divided by 50. Sorry, just getting my calculator. 3,000 divided by 50 gives me 60. If I do the other one here, I would have y is greater than or equal to negative x plus 20. So again, you want to pick an interval that's the same for both here. Now, the highest are going up is 60. Let's see if going up by 5s would work. Because as we saw here, going up by 10s, we have a very small window. So going up by 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. I can do that. So going up by 5s looks like it works here. 10, right? And hopefully you realize too, I think I mentioned it before, when I'm graphing here and labeling my intervals, I don't need to label every single interval. I know I'm going up by 5s, but I'm labeling or skipping every other one here. So I start at 60 here with the blue, the top inequality, and I go down 3, 1, 2, 3, over 5. 1, 2, 3, 4, 5. Down 3, 1, 2, 3, over 5. 1, 2, 3, 4, 5. Now, as you can see here, when I graph this, and yes, it's going to be a solid line. You know, I don't go through the x-axis, which is fine here, but it will give me a better idea. So as I said, we shape below. And then to do the other one, we start at 20. Go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Solid line. And then my shading is going to be above. Now this gives me a better idea of solutions here, right? Because I know anything right here is going to work. So I can have, so instead of trying to figure out in that small space there, I have a larger space I can work with. So I can have as a possible solution, I don't know, 40 weekday and 10 weekends. I could have 40 weekdays and 20 weekends. All right, so that's how you do word problems with linear inequalities. So what I want you to do is I want you to try to next 3 on your own here, and then